Hi everyone, let's take a look at the product rule for radicals. If you have the nth root of a times the nth root of b, so the indices are the same, then you can multiply the radicands together and have the same umbrella of the index. So that's all there is to it really. So let's take a look at a few of these. Feel free to work ahead and hit pause if you think you know how to do this and then check your answer when I'm done. But I'm going to go ahead and work these now. So the square root of 2 times the square root of 7, square root of 14, boom, done. The square root of 17 times the square root of y, the square root of 17y, boom, done. The cubed root of 2 times the cubed root of 32, now be careful, there's an extra step on this one. It's going to be the cubed root of 2 times 32 is 64. Now 64 is a perfect cube. 4 times 4 times 4 is 64, so your answer here is 4. Now let's look at the fourth root of 6 times the fourth root of 3x squared. So that's going to be the fourth root of 18x squared. So you look at that 18, you're thinking, you might be paranoid now. You're like, well, wait a minute, is there a perfect fourth power I should be able to pull out of there? No, not in this case. How you know is you look at the factors of 6, that's 2 times 3, right? And then you got this 3, so you're looking at a 2 and 2 3s that multiply to be the 18. So I don't have 4 of the same factor to pull out of there. So it turns out that's as simplified as that guy's going to get. Looking at fractions, this guy looks intimidating, but it's not that hard. The square root of 3 over x times the square root of y over 2 is going to be the square root of 3 times y over 2 times x. There it is. So there really wasn't too much involved with that one at all, as it turns out. Next up, we're looking at part 2, or we're looking at the next video in this sequence. It's going to be the quotient rule.